Okay, so our first problem, we want to solve the following differential equation. We have this equation, and we know that y of pi over 2 is equal to 2. So the first thing is to find the antiderivative of this function. Because basically what this is saying, if you were to translate this into English, is this is saying, what's the function? What's the function y equal to so that its derivative is equal to 5 cosine of x. So it's asking you to just work backwards. And what's that function? So since we're just starting off, we would say, okay, well, I know that the derivative of sine is equal to cosine, so I probably need a sine here. And then you know that when you get the derivative of a function times a constant, the constant just stays there. So you assume that the same thing happens with antiderivatives, and in reality it does. So what you can always do is you can always check, you can always test by getting the derivative of what you just found. So if you got the derivative of 5 sine x, 5 sine x, does that equal to this function? Well, yeah, because the derivative of 5 sine x is 5 cosine of x. So you can always test when you're finding the antiderivatives. Okay, now, this isn't entirely correct because you're missing something. You're missing that this function right here is the antiderivative of this, but plus any constant. That's because when you get the derivative of a constant by itself, remember, it's 0. And so any number that you add here is going to be okay. So, but you have some information. You know that y at pi over 2 is equal to 2. In other words, when x is equal to pi over 2, y is equal to, y is equal to 2. And so then all you need to do is you go, okay, well, when y is equal to 2, x is equal to pi over 2, then what you can do is you can solve for c. So you go, okay, well, just plug it in. 2 is equal to 5 sine of pi over 2, that's 1, and then plus c. And this means that c is going to equal to -3. And so then your result, your solution to the differential equation is y equals to 5 sine of x minus 3. So this is the differential equation, this is the function that satisfies the differential equation up here. That when you get the derivative of it, it equals to 5 cosine of x, and when you plug in pi over 2 into the function, it equals to 2. And that's it. Check.